have a couple, as I mentioned earlier, Zero Net Energy demonstration projects. Those are both CEC-funded projects with several great partners. Whole Foods, which was mentioned earlier, is one. Chinatown Community Development Center is another. The engineering firm Arup and RMW and Integral Group as well as a couple national labs. But I don't want to take up too much more of your time. I want to leave a lot of time for our great companies. We have 4 companies presenting today, and with that, I'm just going to go ahead and introduce Liam Berryman from Nalumbo.
So, hi, how is everyone? Can you hear me? Great. So it's my honor to go first, and we'll see how this works with a PDF version of our slides here. I need a bit of help, Tim. Perfect. Okay, cool. So, hope everyone's doing well. It's an honor to be here. Thank you for the introduction, Tim, and I'm really looking forward to the panel with all these wonderful different companies and people. So this is going to be a quick overview on Nalumbo and background on how we got started and what we're focused on doing now. But the primary thesis of the company is really that there are a number of different challenges and problems in the industry of heating and cooling that are traditionally solved with mechanical means by changing component design or equipment design. And it actually turns out that the latest developments in advanced materials can be used to more elegantly and in some cases more cheaply solve these different problems in these cooling systems. So the company Nalumbo is focused on looking at these specific problems in heating and cooling industries and solving them with new advanced materials methods. So the overview of the company is that we are focused on these critical challenges in heating and cooling. One example is frost and ice buildup in low temperature cooling equipment. This is a big challenge that the industry deals with today. We've developed our first products and we're bringing these to market and also working with some component suppliers to the industry to scale up our product prototyping capabilities. We've been previously backed by the U.S. Department of Energy. That's how we spun out of the University of California, Berkeley, about a year and a half ago at this point. It's through a $100,000 grant to the company for our technology and for our team. And then we went on to raise a venture capital round at the end of last year. Included some energy executives, some venture capitalists, and then we've just recently got accepted at the Cyclotron Road program, which helps to commercialize very difficult materials and energy-related technologies. It's based, again, back up at Berkeley. So we moved out of Berkeley, we went down to Menlo Park, opened up our pilot prototyping facility, and then got sucked right back up to Berkeley now, and we're now a team that's spread across the 2 different locations. So the problem that I talked about, one of the biggest problems in low temperature equipment industry that we're focused on first is, again, frost in medium and low temperature cooling equipment. Just to give you an idea of what happens in, say, a typical supermarket as an example. During the normal operation of equipment, you start to build up frost and ice just because this equipment is cooling air at temperatures below 0. The issue with that is that the frost immediately lowers the overall energy efficiency of your system. But the biggest challenge to owners and operators of this equipment is that they actually have to shut off their systems to do what's called a defrost process and remove that frost and ice that's built up, which is a really big danger to all the food that they're storing. So this is just one example of the different problems that an owner and operator of low temperature, even medium temperature refrigeration equipment can hit. And in addition to this, it's both a problem for the owner and operator of that equipment, and it's a problem for the manufacturer, because the guy that's designing this equipment has to build in these expensive auxiliary defrost systems, both with software and actual hardware components, to deal with this problem of frost takeover. So, what we've looked at is really, what is the core of this problem? There are a number of different sub-market industries that have focused on all the different problems that are listed on the bottom left. Lowered thermal performance with water, ice, and dirt buildup on these different components and cooling equipment. the ice buildup, the accumulation of mold, the accelerated corrosion that happens. But all of those different companies have focused on these sub-problems or these downstream symptoms of what the root cause problem is, which is really just condensation. It's the process of forming water on a cold surface. This lowers the efficiency of your air conditioner. It leads to frost and ice buildup in your refrigerator. And so what we focus on is solving that core root problem. And the material that we've developed is what's called a droplet ejection technology. This is a coating that when you put it on a surface, the moment a water droplet forms, it will actually physically jump off of that surface while it's still a micro droplet. And that means you can maintain, even at sub-zero temperatures and very high humidities, you can maintain a dry, frost-free surface, solving all the different problems that happen from this water buildup issue. So then going to our team, just want to tell you a little bit about us. My background is I was doing chemical engineering at University of California, Berkeley. I have some background in entrepreneurship as well. I'm joined by Lance Brockway and David Walther. Lance Brockway was one of the researchers for this technology when we were back at Berkeley, and we joined forces with David Walther upon leaving the university to commercialize the technology and scale up our process. As I mentioned, over the last 12 months, we raised our first round of venture capital. We've also expanded the team to 5 people full-time, opened our pilot production facility in Menlo Park that has allowed us to get full-scale, commercial-sized samples out to first customers and interested partners. And we've also brought in a few advisors that I personally really enjoy working with, including Mike Hopkins at Ice Energy, someone that I think a few people in the room are familiar with. Ice Energy does ice battery storage technologies. And I think that's it for my time and for my presentation. Thanks very much. Looking forward to the panel.
Thank you, Liam. Next, I'd like to invite up David Miles from Software Motor Corporation.
Okay, thanks, Tim. Can everyone hear me okay? So it's a pleasure to be here today. It's great to meet everyone and to kind of share some experiences with some of the other startups here. So Software Motor Corporation, we're a 3.5, 4-year-old company now, founded in Silicon Valley by some serial entrepreneurs, run multiple successful startups in the past, the last of which was sold to General Dynamics in a very different industry. And they were looking for the next kind of big thing that they described in terms of what they were going to do next after that acquisition of the previous company by GD. And they came across some technology that was being touted on Sandhill Road, and it was there'd been a company formed out of a professorship at Illinois Institute of Technology where they've been researching a new type of electric motor over the past 15 years. And the technology, the motor technology itself is called a switch reluctance motor. And that technology has been around for about 150 years, but to make it commercially viable has required the cost of the power transistors, the high voltage power transistors to drive this motor to make it work, make those commercially viable. So previously those transistors, and there's 6 of them required to drive this motor, they've previously been about $150 each, and before that they would have been in the $1,000. So more recently, with the advent of EVs and other high-volume applications for those components, that cost has come right down to make it that we can get a little module now for $10, $20 to drive this motor. So the number of things have come together to make this motor technology effective. One is the lowering of cost of those components. And it is a software-driven motor. It's not like a traditional motor where you connect a voltage out to it and it spins. It actually requires a drive, and it requires some fairly sophisticated software to drive the motor. The motor itself is a very simple construction, much simpler than traditional motors. Now, the advantage of that, it means it's very highly reliable, and it's also low cost. Okay? So the complexity we found was not on actually making the motor work, it's making the software work to drive that motor. And that took probably 2.5 years to 3 years to develop. And there's some very high performance digital signal processors and some pretty sophisticated software now making that motor operate. And it turns out, in order to give that motor its operating profile and its high efficiency, which is really where our gains are here, the number of motor poles to the number of stator poles is a key factor in that motor design. And we have some patents around that, which means that this is it's not replicable by the organization. So it's a patented motor technology, it's software driven, and we have a number of components that make that work. There's the motor itself, which you're seeing a kind of cutaway picture of here. There's a drive and the software that goes with that, and there's an automation controller that can be bundled with that. And together with that, we have some programming software that enables it to be easily programmed and commissioned into a commercial HVAC system, which is where we see the initial target market. So in terms of the market itself, oops, I'm having problems with this, Tim. Use the keyboard? Okay. So when we started off in this, being the last companies we'd run had all been IT companies in the IT space, we were thinking of data center applications for cooling fans. But it turns out the NREL, the National Renewable Energy Labs, have been tracking this technology that was being developed at IIT for a number of years, and they called us up and asked us what we were going to do with this. And we told them, and they said, well, do you realize that's only 2% of the world's energy consumption, or the US energy consumption? If you were to look at the commercial HVAC market, that's 40% of the US energy consumption. And the fan blower motors in those systems themselves are 20% of that. And, you know, when we looked at the market data, the International Energy Agency kind of report that about 45% of the world's energy consumption is electric motors. And we put that together with commercial HVAC. That seemed like a pretty good market for us to go after. And that's where we focused all our energy to date, is in terms of how we can provide very cost-effective energy efficiency retrofit solutions for that particular market. The motor itself has a ton of different market opportunities we could enter up in, but as a startup, we had to provide some focus, and that's the market we're initially picking on. So going forward, we're also going to be looking at pump applications and other kind of aligned areas, but those are the two spaces we're looking at. So you can see the market itself is huge. There's, you know, in our horsepower range that we currently have 1 to 3 horsepower motors. 5 horsepower motors are just going through certification right now with UL, and they'll be available within the next few weeks. By the end of the year, we'll have 10 horsepower motors. And that's the vast majority of motors sold in the US today. About 60-odd% of all motors sold in the US today are in that horsepower range. When we look at data from the DOE, you know, they'll tell us that of all those motors that are in use today, there's about 15 million motors out there today in these applications that don't meet current energy efficiency standards. So that's a pretty big market for us to go after. And, you know, as the market is growing, there's two things happening there. One is it's a growth market for us, but also if something's not done about the energy efficiency of those motors, the demand on the grid is going to go through the roof. So, you know, there's a win-win situation there. And the other dynamic here is that over the lifetime of the motor, it's only 5 to 8% of the cost of that motor, of the motor cost is actually associated with the operational cost of the motor. The rest of it is in the energy it's consuming. So typically these motors and these applications are running for 10, 20 years in some cases. We're actually working with a company right now that's working with a project up in San Francisco where they've got a motor there that's been running for nearly 100 years. So it's, but it's a very old, it looks like something out of Back to the Future, you know, the flux capacitor. But it's, it's an interesting project. So rather than go into more about the company, what I thought I'd do is share some information from some pilots we're running right now. And this kind of shows how we get the energy efficiency savings. So if I explain this graph, on the left-hand side, you're seeing a red bar. And what we typically do when we run a pilot is we characterize the energy consumption of the existing motor system that's in there. And in this case, that's what that red bar is doing. It's showing the power draw of that motor. Then what we'll do is we'll introduce our motor, and we'll measure the power difference that's being drawn by our motor compared to the induction motor. In this case, you're seeing a saving of about 10%. In some cases, that can be as high as 18 or 20%, depending on the type of motor that's in that. So then that's doing a like-for-like comparison. And then what we'll do is everyone knows in this space that adding variable speed control to a motor can create incremental savings. So we'll add a variable speed control element to that using speed points that are agreed with a customer. And then by that, we can see we can get anything from in this particular case, a 32% to a 91% reduction in the energy draw of that motor based on the speed it's operating at in the different heating, cooling, or ventilation modes of that system. Now, when we aggregate that over the year, looking at, in this case, the customer's building management system, we can see how often it's running in each of those duty cycles. And in this particular case, that represents a saving of 69% on the energy bill for that customer over a period of a year. So what we're seeing here is the opportunity, and we've other examples. This was a national restaurant chain. We've other examples in grocery stores, commercial buildings, and very similar stories across the board there. We've also benchmarked against existing variable speed applications. So this was a fixed speed to a variable speed. We've benchmarked against variable speed applications. We're seeing 40 to 50% improvements even over an existing variable speed solution, which is intended to be the most optimal solution. And we get that energy efficiency gain because what most people don't realize is that traditional motors are only specified at their nominal operating speed. So in a HVAC application like this, your motor is specified to run at 1800 RPM and its efficiency is rated at 1800 RPM. When you deviate from that operating point, your efficiency drops dramatically. It can be as low as 50% in a lot of cases, whereas we maintain a flat efficiency curve across the entire operating speed range of the motor. So that's kind of who we are and what we do. And I'll go back to Tim.
Thank you, David. At this point, I'd like to have Lynn Mueller come up.
I think there's probably a reason they put me on after lunch, but I'm Lynn Mueller, President and CEO of International Wastewater. And as you can see by the picture, we recover energy that goes down the drain from normal household functions like showers, laundry, anything you do that creates heat. And as a society, we're perfectly happy throwing away about a third of the energy used in the world ends up going down the drain. So being a little older than these other kids in this opportunity here, you tend to reflect, I spent a lifetime in the energy efficiency business and the geothermal heat pump business, and I was going to retire and spent a few days at home, and my wife said, you better find something to do or a new place to live. So I thought, well, I'd been thinking about this. I got 3 daughters and a son, and they use lots of hot water, and I thought if every household in the world had an energy usage like mine, there's a fortune being thrown down the drain. So it just turns out that the Department of Energy in the United States did a study about the same time I was thinking about it and determined that $40 billion a year in waste hot water is put down the drain residentially in the United States. So when everybody in the room is Liam and David and this lady are talking about how you raise money to run a company, I think the secret is what you have to realize at the end of the operation, you're going to have a small fortune. Unfortunately, at the beginning, you have to have a large fortune to kick it off. So that's the first key to developing that. So every day, everybody puts energy down the drain. And it's really easy to understand. When I go to people and tell them I want to recover their heat from the drain, they go, yeah, I always thought there was a lot of energy going down there, a lot of heat going down the drain. So very easily adapted technology. We have 2 basic systems. One that will do a single building, so our goal is to do every single building in the world, recover the heat. And the other one, the SHARC, which really isn't a fish name, it stands for Sewage Heat Recovery, it just was kind of a catchy acronym. And that'll do district energy systems. So when we look at connected energy systems and microsystems, absolutely perfect for that application. We're maybe a little further along commercially than some of the companies here, but we just got a job in Scotland, for instance, to do 80 acres of new development will be on a sewage heat recovery system, but it also does heating, air conditioning, and makes their hot water while saving energy, carbon. And we're really the classic decarbonization system because everything we do, we recycle, so the energy you use today goes down the drain and you get to use it again tomorrow. We work well in synchronized systems, so if you've got the synergy of multiple applications, the common thread can be being able to either extract heat from a sewer line or put heat into the sewer line when you're air conditioning. The sewer is a common artery to every city in the world. You can get your internet from 100 places, electricity, but there's only one sewer system, so all the flow goes down there. You look at a city like San Francisco, it's probably 300 million gallons a day flows through their sewer system. And then you wonder why people bother to do things in their life. And is that I want my legacy to be more than just what I've done, and thank God for that, because I've made so many mistakes, I wouldn't want that to be my legacy. But I've been fortunate enough to have my youngest daughters join the company, and that's a picture of my little granddaughter that I now live and die for. And I want to make a difference in the world, and I want to do it, and I want to be commercially successful, but I want to have a legacy that endures. And, you know, we have a little motto around our company that we want people to work for us for life, to be fulfilled, to make lots of money, to enjoy their holidays, have an opportunity to enjoy life while doing something good. And raising money for that dream is probably tougher than it sounds, but looking forward to the panel discussion to talk about that, and that's the waste heat recovery business.
Thank you, Lynn. Jennifer?
Cool. Thank you, Tim. And thank you all for being here today. It's a pleasure to be here with the co-panelists and sharing with you about Kiwi. Kiwi is we built a solution to make buildings smarter at the outlet level. And like Tim said, my name is Jennifer, co-founder and CEO of Kiwi. Before I get more into what our solution is, I wanted to share a little bit more about how we began to embark on this journey for me and my co-founder. So for myself, I grew up in this really small town in New Mexico of about 10,000 people. There wasn't a lot to do there, so blue skies and starry nights was kind of how I spent most of my childhood. And it really shaped a lot of, my beliefs and values, and it has led me to pursue a degree in civil environmental engineering. And along the way, I was exploring different projects in the sustainability space to work on, and I just kind of fell into plug load management, which are the devices that are plugged into the outlets. And I remember my first project was making cable boxes more energy efficient, working with DirecTV. And I was being exposed to different technologies like occupancy sensors and timers and how those two will work together to reduce energy consumption for those devices. That was a really great foray into this space and the technology, and I also realized that technology may just be one aspect of a solution to really tackle energy efficiency successfully. I worked on a number of different projects that worked on engagement and behavioral modification from that perspective. So for example, one thing was building an app that actually, we were fortunate to win the prize for the Department of Energy competition. And what that app did was it took a lot of residential consumer information and took that baseline energy consumption information, uploaded it into things like a Tetris game. So the difficulty of the game for the player would vary based on how much your baseline energy load was. And I was just really astounded at how people were very receptive, and it was a really interesting way to engage with people in energy efficiency. So my takeaway from that experience was that you need both technology and something on the level of behavioral modification and engagement to truly tackle this space as effectively as we could. I came to Stanford to do my master's, and when I graduated, I had been I've been away from this space for a few years, but I took a look and realized that there wasn't a lot of progress, unfortunately, being done specifically for plug loads. And that was about the same time I met my co-founder, Hetty, who had just returned from being in Germany for about 2.5 years on an expat assignment after completing her PhD. And she was really shocked that in the European countries, they treat energy conservation very differently than we do in the United States. So we had that in common, and we wanted to try and do our best to make a change on that level. So that's why we decided to work together and start Kiwi. So the problem that we're solving, like I mentioned, is plug loads. Plug loads are the only energy costs that are expected to increase 150% in the next 20 years. And they're going to be hitting, over $100 billion in the commercial industry alone for commercial buildings. And as you can imagine, part of the reason for this increase is we all have more than one tablet, smartphone, computer per person and per household than we did 10 years ago. If you look at plug loads, ventilation, and lighting, those are the typical components that make up a building's total energy consumption. Plug loads can actually now make up as much as 40 to 60% of a building's total energy consumption for highly efficient buildings. So it's definitely a growing problem. And to compound that, not only do we have an increase in the quantity of devices in our homes and our workplaces, we are also seeing now that everyone is leaving their devices on all the time. So even if you leave work at 6 p.m., for example, all your devices are still left on 24/7. And so this is definitely a very, very, it seems like an easy problem to solve, but unfortunately it's not happening. And these are problems that our customers have struggled with. And that's why we've been really excited to work with these different institutions, these leaders in the field, to help them tackle this problem of plug loads in their facilities. And how we do this is through both technology and engagement. We have a three-pronged approach. The first is awareness, second is control, and the third is engagement. So as you can imagine, for plug loads, the main difficulty initially is just knowing what your plug load consumption is in your building, on an aggregate level as well as on an individual level. So what we do is we go in and we make outlets smart by plugging in the devices into our hardware. We can start to monitor energy consumption in real time, and we stream this information to our cloud server, where we then have built software applications to help building administrators get a better understanding of what's going on inside their building. Not only do they know how much plug loads make up their building, they can also break it down by floor to the specific device level and start identifying, what types of devices can they swap out, replace, improve, and where can they start to, set actionable things such as setting schedules to mitigate the effects of plug loads. So that's the first step. The second step, like I mentioned, is control. So now that you have awareness about what's going on inside your building, you can start to take action. Each of these smart outlets have a relay switch, so you could turn devices on and off remotely. So if you imagine in a building like this at Microsoft, people may come in at 8 a.m. and leave by 6 p.m., for example. They may not turn off all their devices, but the building manager can, with a click of a button, put all these non-critical devices on a schedule and have them turn off at 7 p.m. and back on at 7 a.m. So very easily you get 12-hour reduction in energy consumption and costs. So that's something that has been really effective and is very easy for them to do once they understand what's going on inside their building. And the third part is engagement. So it's very difficult because, specifically for plug loads, as you can imagine, compared to HVAC, the building manager is the one that sets the thermostat, for example. And then we all just kind of have to suffer through it, whether it's too hot or too cold. No one seems to ever be 100% satisfied. But for plug loads, it's very, very different. You can't go to all your occupants and say, hey, everybody turn off your devices at 5 p.m. and you can't turn it on before 8 a.m. I don't think anyone would ever abide by that. So that definitely does make it more complicated. And so what we've done to help combat that is we've built a mobile application. So with our mobile app, each occupant, whether you're an employee or a student, you get to see exactly what the consumption levels are for each device that you have in your cubicle or in your room. Then, to incentivize them, because they don't pay the electricity bill every month, you can earn points for actually reducing your energy consumption over time. You can earn points for setting schedules for your devices. You can even earn points for answering questions correctly. We also have a gamification aspect where you compete with each other and within organizations. So like marketing versus IT, who is better at reducing their energy consumption for plug loads. And so this has been something that's been really effective in helping tackle this problem. And this is the first very holistic solution that has been on the market to address these issues for energy efficiency. So, we've been around about a year and a half, and it's definitely been an adventure. We had our 12th deployment yesterday for a building, and we're constantly learning. But so far, we've been able to see about 30 to 90% energy reduction for plug loads in a building, depending on the type of building and how complicated their use cases are. So that's pretty much what I had. Thank you for listening.
All right, thank you. At this point, I want to invite all our presenters up for a panel discussion. One more hand for all of our presenters, actually. Sorry, I want to turn the screen off if that's. All right, I have microphones, so we're cordless. Well, one of the main questions I wanted to kind of tackle was, it's hard to launch a new product and new industries. And what kind of support would you like to see from other entities? Let's start with government and policy, for example.
Yeah, well, most of the time, it would be great to see any support from government. It's a well-known oxymoron when we're from the government, we're here to help. So I'm a little cynical in my old age too. But anyway, government policy is huge in any industry. So the great idea you have, if they just make it part of their policy, would be so easy, or my idea, or anybody's idea. So policy would be great. Getting through to the right people is a tough part. So you can tell us how to do that.
I wish I could. I definitely echo what you said. Policy, regulations, there's just so much regulatory things to have to really understand and have to like go through. Maybe, having webinars and groups that can come together and, specifically like energy efficiency or whatever, our different respective sectors are, we can really have that kind of a support in terms of just education and information, so that as a small company, we're not kind of spinning our wheels trying to say, okay, like what does this like 5,000 page document point to this 10,000 page document, and how do we go through all that information?
My answer is mostly based on what they just said, better accessibility. But I also think that it would be helpful to us if there was better communication between government regulatory bodies and our actual customers, the manufacturers of this equipment, as they put new regulations in play. Simply because sometimes the government actually creates a new regulation that they believe to be helpful or advancing a certain cause, and manufacturers, for a technical reason, can't implement it. And that harms both the manufacturers and the new energy efficiency technologies trying to get into the marketplace. So I think increased communication among all the groups on the table is necessary.
Yeah, I kind of go along with that. A good example of that is in California, there's what's called the net zero energy policy. And by 2030, I think all new construction has to be net zero energy. And I believe it's 50% of existing commercial properties have to be net zero energy. But when you actually talk to people about that, and you talk about the people providing these solutions, they don't know about this stuff, they don't know how to do it, and to be honest, they don't care. So it's really how we can actually drive down some of this legislation to make people act on it and enforce it. I think that's a big challenge.
All right. Well, thanks. Same question, and kind of targeted toward the design community. You know, often they're gatekeepers to new technology.
That's a very hot topic for us at International Wastewater, because we need to really get to the initial design of a building. So we've got to go see the architects, and really not the design engineers so much, but most of them are busy. They're trying to run a business, and you know, the world doesn't have a lot of time for a new idea. And maybe there's just so many new ideas coming through the door they can't get to them. So I think the secret really, you know, that kicked us off is that we're just persistent, and you know, you just need to get one foot in the door, and then just force your way in. So being very fortunate in the design community to know quite a few people, and you know, we went to our local city first, who was intent on carbon reduction, and we had them kind of push us through the door to get to the people we needed to see. So if there was some sort of incentive for them to bring out new designs, that'd be wonderful. But in Canada, it's quite the opposite. They don't have an incentive to do new and stick with the status quo, but you know, you just have to force your way in. So.
For us, it's like one of our biggest challenges for market adoption is awareness. As you may recall from the presentation I just gave, plug loads are literally the last frontier. Most people try and tackle HVAC and lighting first, and then what's remaining are plug loads. So not every organization has hit that yet. Plug loads haven't made it to the top of their list yet. And so from the design community, I think what would be really helpful is, you know, they're at the forefront of everything. They're the ones designing the buildings and dictating how things are going to be built, and buildings last a very long time. So being able to, you know, have them help, you know, articulate and push the envelope from that respect is something that would really be helpful for our entity.
I have actually, again, I have nothing further to add other than persistence in getting to the right people in the design community. It is, at some levels, a game of understanding who's going to be able to actually make decisions and who's the right person to have a conversation with. So, you know, some of that help comes from working with folks like Prospect Silicon Valley and making sure you're talking to the right group initially, making sure you're talking to the group that's even targeting your area of the industry that you're looking at. And I don't know if there's anything to be changed about that. I just think that's a natural phenomena.
Yeah, so I think as it relates to the design community, we've kind of had a bit of a mixed experience. In that we're making motor systems, the design community doesn't normally get into the granularity of specifying components that will go into a larger packaged HVAC system, for instance. They kind of expect the OEMs to kind of do that job for them, and you know, when they go to an OEM, you know, a train or a carrier, the like, they kind of expect that they've already looked at that. But you know, for us, you know, we decided not to target the OEMs initially, simply because it's a long sales cycle and they have other priorities on the schedule right now. I mean, they're looking at refrigerants, you know, all the new refrigerant legislation that's coming down in place, for instance, and you know, motors and efficiency aren't necessarily top of their agenda, even though, you know, the efficiency thing should be. So we've found that to be a difficult market, and I think we've pitched to most of the big design communities, certainly in the California area, and you know, these are companies that are doing big net zero energy project, new construction projects, and they understand the value proposition, they get it, but it's not something they feel confident to specify. And you know, our route to market has been more through the mechanical contractors who are providing service and retrofits and upgrades and maintenance services to the customer base versus the design community itself.
Oh, thanks. So, you know, many of you guys have pointed to, you know, needing, you know, persistence really to get, you know, pilot projects in and early adoption. You know, one question I have is how are you building trust with your customers early on? Like, because that is, a very, very important thing to foster when you are brand new technology.
Start down there.
Start down the line? Okay. So I guess we've been lucky enough to be working on a number of incubator programs, whether it be with Prospect SV or NREL and other organizations. And we have one particular champion in one of those, I won't say who it is because I don't have his permission, but he's been very vocal about, our solution be revolutionary, it's the way forward, and he's created some introductions to CSOs, very senior decision makers in companies, persuaded them that they've really got to look at the technology. And that's worked in our favor in a lot of ways in terms of getting low-risk pilots and trials started with those companies. And what we tend to do is when we put a trial in place, we will do it in such a way that it's easy to go back to the original solution. So, we replace the motor, but we find somewhere in the cabinet that you can leave the old motor and it's an hour to swap it back in, for instance. We also always, so our motor system is IoT capable. So, we heard this morning in the keynote that IoT is the way forward here. And we see a lot of resistance to that in a lot of cases because the market's not quite ready for it in some areas. But in that we have that capability, we have the ability to monitor the effectiveness of that solution in real time whilst it's running in a pilot situation. And that's helped us in a number of cases. It's actually made them more convinced it's the right solution. We had one example, I think it was a restaurant down in Southern California, we're 400 miles away, and we noticed that the motor wasn't running when it should have been running. And what had happened over that weekend, they'd had an electrician in, that electrician had done some work and he'd miswired a number of circuits. So he'd connected our motor up to a lighting system, and every time someone turned the lights off, the air conditioning system stopped. So we were able to let the service company for that customer know about this before even the customer realized what was happening. So that turned out to be a win-win in that situation because of the way we monitored the system.
So in terms of building trust with customers, for us, it's been, first thing is we've done a pretty good job of trying to make a physical demonstration of what we do and get that in the hands of as many different people in the value chain as we can. Because our customers typically are the manufacturers of this equipment, and so they actually want to see it. They want to understand it's real. They want to understand it's going to last for a very long time. But they also want to hear their suppliers saying, "Hey guys, this is," as you put it, the way forwards. They also want to hear their customers saying, "Hey, we want this." And so it is a journey of persistence. It takes a long time. It involves some pain in some situations. But I think it's consistently demonstrating to all the different people that are going to be talking about your product and what you do, that what you say is legitimate.
Yeah, I want to definitely echo what he said about physical demonstrations. That definitely helps build the initial trust. We've been really fortunate. I think what's also helped for us is that our first two customers were seen as leaders in the field, so like SFO Airport, Stanford University, and they were feeling the pain of plug loads big enough that they were willing to engage and work with an early stage startup like us. And because of that, we had the opportunity to build the business case as well as the credibility of the technology working. And that's helped us in that, trying to expand, our market and to different customers, we have that, referenceable customer to point to. So that also does alleviate some of that mistrust that initially happens, and that has been something that we've been able to try and take advantage of. But it's definitely still difficult.
Thank you. With me, and being a little older than these kids here, but one of the things I underestimated was I'd never heard of Prospect Silicon Valley, and I wish every part of the country had this sort of thing, because it's a phenomenal incubator, but it puts you together with other people of the same mind. So I sat through some presentations in San Francisco and stuff with some of your people, and the things I learned, about artificial intelligence and predictive analytics, we just don't have exposure to that in Canada. And it's so common amongst the technologies here to be so far advanced. I don't know if you guys realize it, but you couldn't be in a better place. And then customers are customers. If you have a good product and you believe in it, and you can get at least to something to show them, whether it be a study or whatever, and you can convince them you've got the technical background to do it, I think it's great. But one of the best things our company ever did was to be invited here to prospect Silicon Valley and be associated with them, because the credibility of being surrounded by the genius that lives in this area of the world is just amazing. So yeah, persistence. And I'm a person that I've written over 500 patents in my life, and I've had maybe 2 of them work out. So I'm used to failure. So when it does, you get some things like this, it's just absolutely uplifting.
All right, thanks. Yeah, and thank you for all the regional praise, Lynn.
Tim, not so much, but the rest of the crew's pretty good.
What do you see as your primary challenge in getting to further market adoption? To get to further market adoption.
Yeah, I think once you've proved out your technologies, and all of these guys have got wonderful technologies, and we do. I think when you commercialize it and you have to make the choice between your beliefs and the commercial endeavor, it becomes the tipping point when most companies fail. So I think you can commercialize things, and the golden rule kicks in. The guy with the gold makes the rules. So you have to find a balance. I got a million of them. Should have been a comic, but. The guy that's paying the bills really dictates where your company goes, and we've been able to maintain our desire to be a sustainable company inside and out. But we also had the advantage of everybody seems to kind of understand that they throw away a lot of energy every day, and we're just getting it back. So we have an advantage that people see the need for it. All that warm water eventually goes down and melts the river, melts the Arctic ice cap, and a third of the energy used in the world ends up going down drain. So we had a lucky break, because why wouldn't you want to be in the sewer doing your job? So it was pretty good. I think these guys are really onto something too. So any worthy technology, I think you break through. But the tough part is, and when you accept that first commercial money, and being able to hold on to your company, because what everybody else wants to do is rip it away from you.
Yeah, so for Kiwi, I think like I alluded to earlier, for us, a big barrier for market adoption is awareness. So like I mentioned, plug loads is something that's not at the top of people's list. And how we try and work with that is we built into our sales process an auditing portion. So for customers that may not know exactly what their plug loads are, we go and we perform an audit for them and share with them what their usage profiles are, what the impacts are, both monetarily from a money perspective as well as from a sustainability perspective. And most of them are really surprised at the end of the period to see like, wow, this is a lot more than I had even imagined it would be. And so then they want to continue to engage with our services, even post-audit, which is pretty cool to see.
So our kind of next biggest challenge in the commercialization process is pretty simple. It's bigger production capabilities. It is, for those of you that don't know, extremely difficult to operate a chemical process in near downtown Palo Alto, as someone would expect. And so we need to go to larger facilities, probably out of state, to actually accomplish applying our products to bigger than commercial scale equipment, which is what our customers really want to see to move forwards.
Okay, so commercialization. Where to start? So I guess, so one of the things that caught us surprised, I mentioned that previously we come from an IT space, a technology space, which is full of innovation. And we always think of innovation being good, and people want to take advantage of that and to create a competitive advantage. So one of the things we quickly realized in the space we're in is it's an extremely conservative market. It's also a very fragmented market. There's a handful of OEMs, but I mentioned that for us, going after the OEMs is a very long sales cycle. For a startup, getting cash flow to keep operating on and getting early revenue is really important. So the path to market to us is through the mechanical contractors, the people who are providing service and retrofits, upgrades to end customers. But there's 1 million and one of those across the US, and it's finding the right ones. We've seen so many people that claim to be innovators in this space around energy efficiency, and it turns out they're innovators about how they use what they've got, not how they actually be early adopters of new technology to innovate and provide the next leap. And we've also found that people don't believe. You can go there with PowerPoints and they just don't believe what you're telling them. You have to show them first. We're going through we're preparing for a Series A round right now, and we had the same thing with investors. You tell them, well, this is a great story, but how do I believe this? And when you go and actually show them the results, they kind of take them back, and it's like, wow, you're really onto something here. But it's finding the people that really believe that and want to be able to have that competitive advantage. And that's a tough challenge simply because of the fragmented nature of the market. And they are out there, but they are few and far between. And we're lucky to have been introduced to a number of those, but it's hard work.
Are any of those in the audience today? The hard to find ones? No? Thank you, David. I guess we should just open it up to Q&A. I'm sure you guys have lots of questions about these technologies, so we can go around with a microphone. Just take one of those.
Thank you. When you were in the starting process, did you engage the workforce development to work with you? Who will do your product? Who will implement your product? How do you train your people?
Do you mean from a deployment strategy in terms of how a customer would use it? So the way we've tackled that is, our system to be best utilized requires some programming for the platform itself, and we've done a number of things to make that easy. One of the things we find is that in the traditional market, where we're looking at what we call variable speed upgrades to packaged HVAC systems, you can do some of that, and people put these what they call variable frequency drives onto a motor to control its speed. But the skill set of the technicians that are actually installing that doesn't usually work out, and they either don't know how to do that correctly, or they do it badly, or they just don't wire these things in. So one of the things we've done is we've de-skilled that piece of it such that you can pre-program these before they get installed by people with the right skill set, or you can program them over the internet. But also, when it comes to the larger onboarding companies to be able to sell and install your products, we do train those companies on. We typically bring them in-house for a day. We do some webinar type training and get them familiar with the products.
Any other questions? Yep.
Yeah, her question maybe, oops, sorry. Okay, so her question was kind of interesting because I've worked for both the UC and I work for the county of Santa Clara. And a lot of times we were at the UC Santa Cruz, we were trying to install a new zero waste kind of a total operation that used a lot of innovative stuff. And one problem we had was exactly what you're saying, the capacity of current staff to deal with the things that you're installing. And I think everyone here, all four of you kind of represent this whole idea where you'll get all this new technology and things. And I also have an architectural background. A lot of the experiments of the 70s required kind of innovative operators, and they didn't exist, and everything failed, or largely. Like your brutalist buildings around, the United States and Canada didn't do well because nobody knew how to do it. Have any of you ever thought about pairing up? Here's my question. So have any of you ever thought about pairing up with someone that would manage that operational side? And I'm sure I know that I had just seen a presentation from a building operational company, wide scale. Have you thought about that side of it, having the capacity? Because these are all difficult. I mean, I understand variable speed motors. I understand the stuff with the HVAC, coding, but to operate it would be extremely difficult and for most staff. How do you go about that, or have you ever even thought about pairing up with someone? That's my question. Sorry.
Everyone's looking at me.
Yeah.
I guess some of the other folks would have got an answer to this, but I can talk to that briefly, and we are doing that right now. For instance, we're working with software companies, for instance, that measure some of the energy efficiency of buildings at the building level, and we're providing mechanisms where they can link into our system and extend their capabilities to really be able to monitor and track and make changes to increase the efficiency of the building.
So a couple of things from us. So one is that we've actually designed the product and the implementation of it such that it's not outside the skill set of your typical mechanical contractor. For example, we internally, before doing a retrofit project, will go through all sorts of calculations and look at, what is our component going to be versus this other component. And at the end of the day, we'll say to a mechanical contractor, okay, you're getting this component. Well, it's just the same component you're used to. But when you install it, we want you to make this mechanical tweak of the system, this tweak, and then when you check your refrigerant or whatnot, you'll see X. Now, it's really difficult for us to calculate internally what X is. That takes a lot of man hours for us right now. But from their perspective, the integration is relatively the same. But we have also thought about doing a more formal partnership with a mechanical contractor just to get more internal learnings for ourselves.
I do consulting work for community college, and in California, there is a big movement called Pathways, which, includes educating in multiple levels from high school or from even kinder all the way to university. And, there is a different system. It's called the Pathway, career ladders, or the 2+2+2. And for instance, in the water industry, what you just explained is what happened 30 years ago. And right now, the water industry in California is facing what is called the silver tsunami, where people that started to work in as water distribution or water treatment or wastewater, they learn how to do it in-house. But there was not a formal career for them. San Diego Cuyamaca College was, a little bit in the avant-garde, and they started a program several years ago. In the Bay Area, we started in 2014, but we are expecting, 40–50% of the workforce to retire in the next 3 years. And we're still, developing curriculum for those and certificate programs and AA programs. So my question was, how can you prevent this tsunami to happen 30 years from now? Why don't you start today, engaging your future workforce? And it could be a presentation at a high school or an externship where teachers come and work with you today. So for tomorrow, so just an FYI.
I think you're seeing that. So we hire engineers all the time, but 20 years ago, you would have hired a professional mechanical engineer. Now we hire energy efficiency engineers, guys that are looking for something different. So I think engineering is more of a discipline to stick within guidelines. I think the new generation engineering crew is looking for different options. So we do it, and we're a little different again too, because we sell a complete system. So we like to keep every part of our system in-house so we can guarantee that it works and functions the way it's supposed to. But at the end of the day, we need to train people. We operate all over the world, so we need to train people in India and Australia and whatever. So we also build a system so we can take that knowledge and hopefully develop young people to come along, and that's the only way you can expand your business. So yeah, I think that's a wonderful idea. And there's a change in how engineers are trained. It's not status quo anymore at all. So.
I second what he said, and I think that perhaps speaking for all of us, we would love the opportunity to kind of do more outreach and teaching at multiple levels. It's, from our perspective, a resource constraint to be able to go and do that right now. But I personally would be ecstatic about the opportunity of going and teaching in classroom at any age, even college level, about this is a new industry that's starting to grow. You could potentially go work here. The materials energy efficiency industry. I'd love to do that.
There's a partner of ours, Luther Jackson with Nova, who got a shout out in the opening. He's a great person to connect to if you're ever interested in that. Does workforce redevelopment. Any other questions? All right.
Hello? Okay. I was curious as to what kinds of skills you feel are necessary to succeed in your role and in your field, and how would one go about developing those?
For me, consistently learning what skills are necessary and then hoping that I can pick those skills up as quickly as possible. But in general, I think that you're not going to learn what skills you need, and you're not going to learn those skills without just going and doing it. I do not have as long of a background as most of the folks on this panel, so I think that they're going to be able to speak to it better than I can, but it's a learning on the job process. And if it's your own thing, if it's your child that you're building, you'll figure it out. You'll figure out what you need to know.
Yeah, I'll just quickly echo what he said. Definitely always be open to learning new things. I think is really important, and just being really resilient. There's just so many rejections, whether from fundraising or customers. You have to have a thick skin, and that's something it's okay if you don't start out with, but over time it's something that you would build, and that's also a good skill to have.
I think a good skill is to be able to budget well so you can live with an uncertain paycheck in startup companies. But anytime you do something new, you just have to be adaptable. So none of us really know where our business is going at this point, but you got to have key people that can get you wherever it ends up. And who knows? And I think adaptability and don't be afraid to use your skills. As entrepreneurs that we all are, we risk it all virtually every day, and you gotta have a skill set to go along with that. So
I was wondering if you can make any concrete suggestions, like attending conferences, or are there like workshops that are helpful? Like, what are some ways?
You have to have a lobotomy to be an entrepreneur, because you just normal people wouldn't do it. So unfortunately, I don't think there's a skill set for risk takers and people that want to do something new.
Well, I don't know if this answers your question, but what was helpful for me and my co-founder that helped prepare us for this was there were a number of entrepreneurship classes that Stanford offers, and you don't even have to be a student at Stanford. They make everything available to the public, videos and all that. There's, I forget what it's called, like the Entrepreneurship Leadership Corner or something, where they invite successful entrepreneurs from around the world to come and speak, and they share like what they found to be skills that help them succeed. There's also courses like through the D School, through like Lean Launchpad, like Garage Startup, through the GSB, that you can also look over and try and get some materials on, which has been helpful.
I think getting really good at understanding what makes people tick and what motivates them. Everyone's totally different in what their motivations are, and if you can understand what motivates them, whether it's your employee or one of your co-founders or an investor, potential investor, or a customer, understanding what their personal motivation is. For example, even if it's a big company and it's a company directive, the individual that you're specifically talking to might not close a deal if it's not good for his career with reference to someone else in that company. That's just the way it is. That's just politics that exists everywhere. So you need to get really good understanding what each individual's motivating factors are, and then being able to hopefully influence them in your direction.
Yeah, I mean, I think there's not a simple answer to the question. I think, and to be honest, I think everyone will say that a lot of this comes with experience. It's not something you can go onto a class and learn how to do this. I'll add to, I think we talked about being adaptable and tenacious. I mean, that's definitely one thing, but you have to be able to make very fast decisions, and you have to act fast and move fast in this world to be successful. And you've got to be prepared to take risks, and some of those are big risks at the end of the day. And if you can't do that, it's never going to work. So it's.
All right. Thanks. We have time for one more question, maybe two.
Mine will be fast. Hi, all. Thank you. My question was, as an emerging technology, do you see or are you on the lookout for future competitors? And if so, how are you planning to implement and differentiate from those future competitors? Or what is the R&D that goes into planning for the future, I guess?
Yeah, I think everyone will say they're always tracking what's going on in the market. I mean, you can't ignore what might be happening there, because the next big thing might come along and it might be better than what you've got, and you have to accept that and change with that. So, I think we certainly believe we've got a leg up. We take some initiatives to take patents out and protect our IP such that it makes it harder to reuse that. So there's a number of things you can do along those lines, but you have to keep aware of the market. It's an example that I can't remember, I heard this a while back. One example was before you had refrigeration, people used to cool stuff by buying blocks of ice. And people go up to the North Pole and they bring back blocks of ice, and they said, but those people went out of business when the refrigeration market, and that cycle has continued over the years. As soon as the next new innovation comes out, if people don't take a notice of what's going on in the market, then they're going to be left behind.
I agree with that in general. And also specifically for us, I think it's about being able to educate, because this is a conservative market. I think all of us are operating conservative market, but particularly us in air conditioning and refrigeration technologies. It's a conservative marketplace, and so being able to educate your customers or your potential partners faster than the next guy can is really important. And I think it will make the difference about being commercially successful if you're looking at two different technologies that are both very, very frontier. The one that's able to educate the industry more quickly is going to break in more quickly.
Yeah, and just to add on to all that, for us, we subscribe to the whole lean startup methodology, which is getting out of the building and talking to your customers. The thinking is, as long as you stay close to the customers and you really understand what their pain points are, you'll always, hopefully, be ahead enough to build the features and the product that they want. And that's been really helpful for us moving forward.
I think, competition is what keeps us all going. And, if you're static, you're going to get eaten alive. And if you stay one step ahead of the competition, it's the greatest feeling ever. So, yeah, it's great.
Okay, one more question. Great.
So all four of you clearly have a technology that's impactful. And I'm curious if there's a moment or experience where you felt connected to the purpose of your organization.
Can you say the last part one more time?
If there's a moment or an experience where you felt connected to the purpose of your organization, the impact, or whatever it particularly is.
Every moment for us, I mean, for me, I think it's a little cheesy, but what I was saying earlier about if it's your baby, if it's your child, you're thinking about it constantly. When you wake up, when you go to bed, when you wake up in the middle of the night, worried about, some deal or some, whatever it is. I think you're constantly connected to it. I don't think, if you're not in it because if you're in it for something other than you love what you do, it gets really hard, I think.
Yeah, I mean, I can't think of any specific examples, but usually what happens is what sinks into me is when you hear third-party validate through another source that someone's singing praises about what you've done, and that happens more and more when you get greater awareness. Like Lynn was saying, the greater awareness you've got there, and the faster you can make people aware of what you've got, the story gets out there and you start to hear other people talking about your solution. That's kind of what motivates me.
With one addendum to that was, for us at the very beginning, when we first talked to some folks in the industry, and we heard them, kind of saying through back channels, this is incredible, like this is never going to work. This is so great, like all this won't work. That was actually validation for us, because we were like, no, we're going to prove that it works. It might just be a technology now, but it'll be a product tomorrow, and after that, it'll become a standard.
I'm going to validate for Liam here, because I've been in the refrigeration industry most of my life, and I saw his idea. It's so fantastic, because I know a company out of Heatcraft out of South Carolina spent $50 million devising a technique to defrost that coil faster. Just a few minutes would save millions. By not letting it freeze on it is a bit of genius, and it just depends on how you look at things. I mean, that's absolutely wonderful, Liam. And yeah, so your validation comes every day, and you just keep at it and you evolve. So, thanks, folks.
All right. Well, thank you all. Please give the panelists a round of applause.